Hi everyone, this is Jules Urbach. I'm the CEO of OTOY, and I'm here to talk about the future of rendering at GTC 2023. Let's get started. So I think this is about my 15th GTC. My first one was about 2010. It's been a very long road, a long journey here, but a super exciting one. And when you look back at the decade plus that's been accomplished in those years, it's remarkable. I mean, our mission at OTOY, for those that don't know, is to democratize the artistic pipeline, to make content creation easy for everyone, and to work towards an ecosystem that is conducive to holographic content creation. That means reflectance field capture and volumetric rendering. And also, we live in a world now where AI is becoming so pervasive that we see these tools becoming easier and content creation in general becoming simpler and more powerful. So if you look back at the last 10 years, or last decade really, of our journey through OctaneRender, which is our GPU unbiased renderer, it's kind of been about 5 step functions. We started with images in 2010 and then moved on to animations, cinematic VFX, and today we have almost 30 integration plugins in various content creation tools, 3D software and the like. And really, towards the end of the last decade, we focused on real-time and a little bit of AI. We were integrated in Unity in 2017, in 2019 in Unreal Engine, and today, I think that Octane is absolutely awesome as a production renderer and also becoming better and better as a real-time renderer. And that's where we see the future heading. This is a great slide. It's from our friend Raphael Rao, who's an artist. And it's from an NVIDIA test, which is, can you tell whether something's real or rendered? And I think that is really the test of graphics and GPU rendering in the future is, not only does it look real, but does it feel real? Does it, is it synthetic? Is it created by humans? There's so much that's going on in the world today, and I think that we're all sort of aware of that, especially with generative AI. So let's see if we can predict what's going to happen in the next 10 years, or at least all the way into the 2030s. And I will say that going back to this presentation I did at NVIDIA GTC 2013 with Jensen, where we were rendering a transformer scene, and it was on, I think, 100 GPUs, which had about 40 Octane bench. Well, it turns out today that one of these GPUs on an iPad can effectively match one of the first NVIDIA GPUs, the K520, that was put on an Amazon instance in the cloud. And it takes about 10 years for something to go from a server GPU to a mobile tablet. And that's something that's remarkable. It also gives us a hint as to what may come in the future. So I think the trends that I'm sort of seeing, one, you're going to have unlimited scenes, whether it's from procedural rendering or from some of the streaming tricks that we're going to show in the coming slides. Obviously, AI neural rendering is here to stay. I think that's actually happening at a faster pace than I might have predicted last year. You're seeing just incredible strides from, a year ago, Midjourney, and August, Stable Diffusion, and of course, DALL-E and ImageGen from Google. I think that the other important trend is going to be figuring out who created the content. That's where Web3, crypto, and the blockchain actually has a purpose. There's also ambient GPU computing, which is where we see decentralized computing kicking in, and mixed reality as well. And then finally, towards the end of this decade, I see holographic display panels being really important and a fundamental aspect of how people experience content. It won't just be through glasses and wearables. So to that end, I want to talk a little bit about a partner. We invested in a company called Lightfield Lab, which is a small investor, but it's a rare thing for OTOY to invest in another company. But this company makes pretty special hardware. They make holographic display panels, Lightfield panels, that will eventually power a real-life Star Trek holodeck. And we've been showing off how we've been testing these Lightfield renders for a while now. These panels are essentially tiles. They can be linked together. The current version is about 20 inches by 20 inches, and it's going to high-end location-based entertainment first. But eventually, the economies of scale will allow this to become a consumer display, and you'll see it in devices from televisions to your tablets, and eventually even probably AR goggles. So What does this look like in real life? It's hard to describe. This is an actual video that was released about a year and a half ago on CNET, and it's showing the specular reflections on a light-filled panel. I mean, it's really difficult to express how real something like this looks on a 2D video, but seeing is believing, and eventually these panels will be everywhere. And I think you're going to have this experience of seeing reality as your eyeballs see it, without any wearables, without anything between you and the screen. And that, I think, is going to be a pretty remarkable sea change. You're going to see holographic display panels probably attached to walls and buildings, and there's all sorts of really fundamental step functions that are going to happen from having this be cheap. Now, the one thing that the holodeck from Star Trek does present is, are you seeing something that's real, or are you seeing something that is actually simulated? And it's not just the visuals. This is an interesting case study. This is from the end of Star Trek Enterprise, and on the left is the first episode of Star Trek: The Next Generation. It's a nice bookend because, as it turns out, this series, Star Trek Enterprise, which premiered in 2001, ended in 2005, turns out the finale, it's all in a holodeck simulation. So as you're watching this final episode of Star Trek Enterprise, you realize, well, wait a second, the entire show has been, at least the last episode, has been inside of the future Enterprise, the Enterprise D. And it kind of makes you wonder, seeing this, is it Enterprises all the way down? In other words, if the entire story of Star Trek, and apparently in universe it can be, simulated inside of a holodeck, well then, what's the difference between the simulated story and the real thing? And that's, of course, the fundamental question that gets asked a lot. You have the simulation theory that's been espoused by folks that are looking at the future of rendering and wondering whether or not there's anything in the real world or reality that can't be simulated, at least experientially. And I think that this really is an important question to ask, not just sort of at the simplest level as to whether or not reality is real or simulated, but also whether what we are experiencing is coming from a simulation or a real person. Going back to some of the work that we've done on Star Trek, this is where some of this is coming from. We've been working on a great project called the Roddenberry Archive. We recently brought in an actor to portray Spock, and it was a great performance. It was done with both makeup and digital effects. On the left is Leonard Nimoy from 1979. On the right is Lawrence Selleck, our performer, who plays Spock. And what's fascinating, you can see here on the right, this is what we're going to show later, our iPad client and whole virtual production crew. But what's interesting is we put this out there and we put it on our blog. And just a few weeks back, somebody said, well, listen, the your version of Spock doesn't look quite right. But what's fascinating is that they got it wrong. In fact, they confused the newer version with the original. And that's the thing, is our memories can be tricked. There is something in the back of our minds that just doesn't quite recall things exactly. And, this makes the entire premise of whether or not you're seeing something that's rendered or real even more complicated. I think, human memory is fallible. And it's funny, when you go and watch an old movie, sometimes what you think, the reality of that film was can be very different. And so going back and recreating Star Trek the way we're doing, and even putting out some of these early tests and images, has been a fascinating exercise in understanding how human memory and, the fidelity of our minds work when it comes to art. Now, I want to take a few minutes here to talk about our core product, OctaneRender. It'd be difficult to sort of elaborate on the future of GPU rendering without discussing our own journey and our own product, which has now been going on strong for about 10 or 12 years here. Octane's been the first unbiased GPU renderer that's been put out there for production. It's been used in many Marvel movies, as you're seeing here. Most recently, it's been used for the creation of the beautiful opening titles from The Last of Us. And very proud of this. Also used for the 4K remaster of the Star Trek motion picture from '79. It's a beautiful frame that was redone in 4K for the re-release. It came out about 14 months ago. Now I have a bit of news that makes this even more interesting, which is not just that this image and all these shots were rendered in Octane for the remastered version, but that these actual renders were done on the blockchain. We have a decentralized computing service called the Render Network, and it's using average GPUs, the machines that end users have, to do cloud rendering jobs. And for the first time, we have a major studio, Paramount, using decentralized GPUs to render frames from a major motion picture. This was done November 19th, 2021. It's embedded on the blockchain, not the image, but the actual receipt for the work done. And I think this is fascinating. It just shows that the world of even major motion picture production is not just moving to GPUs, but also cloud GPUs and also decentralized cloud GPUs. So this is something that we have taken great interest in, and I think it shows a robust interest from really all parts of the industry in embracing decentralized cloud GPU infrastructure. So I do want to also show another piece of Star Trek content. This one, we made whole cloth last year for the Roddenberry Archive, and it's a beautiful piece of content. It's about a minute long, and I'm going to play it and let you all watch and enjoy. There we go. That was pretty cool. All rendered, of course, in Octane, composited with some live action plates, and all those renders were done on the Render Network. The other fascinating part about this project was that we did a lot of work with virtual production using the iPad. And in fact, our iPad workflow was featured by Apple recently, and we put out our Octane for iPad app, which again was used for a lot of the work that was done on the piece you just saw. I think that there is a huge benefit to using tablets for GPU rendering. I think that while the GPU on a tablet is pretty low power, it's probably a 15th or 20th the power of a high-end 4090, for example, you can still do pretty good time to first pixel rendering. This is the iPad rendering the scene here. Obviously, it's taking a bit of time to resolve, but it's fast enough for you to block out the scene and possibly do final frame rendering. It's all possible on device. But what's more important is that if you're directing a scene and you have the tablet, you can effectively block out what you're doing and even use your fingers, which I'm doing here to show how this can be, how you can set your camera into a shot. Of course, iPads and phones have AR tracking. So there's a lot of things that are built into a tablet and a phone that a desktop machine or even a laptop might not have. And one of the things that of course enables is really powerful mixed reality workflows. So you can see here on the right, we have a form of light field baking, which I'll talk about in a little bit in greater detail. And that allows us to take a scene that's been effectively blocked out on the tablet, pre-compute the lighting, and then play it back in real time in mixed reality. And we have more sophisticated mixed reality rendering. For example, in this case here, you're seeing real-time reflections being done live in camera. And we can also take scenes that are fully offline, like the one you're seeing on the left, and then we can bring them into a live mixed reality environment on the right. Now I want to take a bit of time to talk about the core rendering technology in Octane. So recapping the version of Octane that was put out last year, Octane 2022, there's some great features that were introduced in that version. We had a photon tracing kernel, which allows you to approximate beautiful caustics almost in real time. You don't need to do Monte Carlo path tracing. You don't have to wait for the caustics to resolve in thousands of samples. Just a few samples will get you beautiful results, and they're really sharp caustics. So this shipped last year. It's in the stable version of Octane 2022. We also added support for Arnold standard surface, which is an emerging standard that's being adopted in other renderers like Redshift, Unreal, Material X. I think standard surface is something that Autodesk had brought to us. We agreed to adopt it in Octane, and I think it's a great BRDF or set of BRDFs that I think is very powerful, very artist-friendly, and we're very pleased to add that in Octane 2022. We've also added a number of material inputs to normalize our material system to the Arnold one. And all of that, I think, has allowed us to enable workflows that are, more familiar to artists that are using Arnold or maybe other production renderers that have a similar workflow, but still leverage all the nice things that Octane adds in addition to that. Some of the other improvements in Octane 2022 include 3 times faster particle rendering, 6 times faster motion blur, and we also enable support for Octane as a render delegate. So you can use it inside of Solaris or Houdini 18 or later. And you see here it's running inside of Omniverse as well. And we've been working with the team at NVIDIA to make sure that Octane inside of Omniverse works beautifully. And we'll show some samples of that as well. We've also spent a significant amount of engineering and resources and time around Unreal Engine. I've been showing some of the virtual production work that we've been doing for the Roddenberry project, and Unreal is a big part of that. Unreal is actually the de facto standard for a lot of virtual production work today. A lot of LED walls and volumes are set up to work with Unreal, and so Octane for Unreal has an important place to play in that ecosystem. For one thing, you can render what you're doing on the virtual stage for final render through Octane. And you can also use pre-computation to bake your Octane scenes for live rendering, and also leverage some newer technology that we've been developing to basically bring the path tracer into the Unreal Live Viewport, which you're seeing here. And the quality can be pretty good, even on a single GPU without any sort of pre-computation. So it's great for setting up your shots. There's a lot of tricks that are being leveraged here, including being able to take previous frames and re-render them. There are also things that we can do to give you a gradient between real-time and offline. Now, I do want to show another bit of real-time technology that we've been actually showing off for about 10 years. It's called Brigade. Brigade is our efforts to take our work in Octane for offline rendering and figure out how best to deliver a real-time workflow experience with path tracing. So these are Octane scenes that were adapted to Brigade. The last few years, we've been showing some of these renders that have effectively cut out some of the Octane features like spectral rendering to deliver near real-time rendering, and it's pretty good. But the thing that we discovered, and one of the things that really kind of made us switch gears, and that's one of the reasons why we've taken so long to release it, I think, has been, artists really want to stick with the workflow that they're used to having in the real-time, in the offline world with Octane. And so we've been developing ways to get Octane with spectral rendering, with all features, all materials, just working in real time. And this is a test version of Octane 2022. But the feature that you just saw where we've had noise-free rendering is shipping in this year's version, Octane 2023. So I want to talk about some of the features that we've developed for this version. One of them, separately from any of the fancier things that are going into the Brigade real-time noise-free rendering, is a whole new light system. We haven't really had analytic lights in Octane. We've had effectively mesh emitters the entire time that we've released Octane, and that's incredibly slow. Analytic lights are a feature that have been in many game engines and biased engines, not in Octane so much. But now that we've added them in Octane, we've basically been able to get absolutely the same fidelity as unbiased light, but at much faster rendering speeds. You can see on the right, you've got Octane 2023. On the left, you have the older version, and the difference is remarkable. So this is before we do any denoising or anything else. We just have really fast spotlights, really controllable spread functions. It's great because it's customizable, it's fast, and when you add the temporal denoiser on top of that, then you get effectively something pretty close to noise-free rendering for very complex scenes. Now, there's still a little bit of noise, but it's about 2 or 3% of what the version from last year had, and I think that's a pretty great achievement. Now, this is, of course, a scene with GI and reflections. When you're doing something as complicated as subsurface scattering, we had to build a whole separate shader system for that, which is what you're seeing here. So in this case here, we're showing Octane 2023 on the left with a new real-time subsurface scattering shader. And on the right is the Octane 2022 engine, and the difference is pretty huge. Now, if you let the Octane 2022 version resolve, you'll see it basically ends up matching what's in the real-time version. But they both converge, just that the version on the left is happening much faster, but you still end up with something that really does reach final frame quality, which is pretty great in real time. We've also taken a lot of time to focus on effects that are in the camera. So, for example, chromatic aberration, lens flares, things like that. They've been possible in post, but we wanted to bring them directly and natively into the renderer. And the results, I think, are fantastic. A lot of people have used the post effects in Octane for a while. It is spectral, and these glints and these glares make a big difference. It's certainly fun to use in the real-time IPR window. And frankly, I've been turning them on all the time for a lot of the art that I've been doing. They are spectrally correct glints. Even lens flares are spectrally correct as well. So these things have really nice high-quality outputs, and they're very fast. Now, we didn't stop at those sort of in-camera lens effects. We went further and did very fast volumetric media. So if you ever used Unreal Engine, there are post-processing volumes. This is something similar, except it is path-traced, and it is fully integrated in Octane's scene graph. And you can see here that you end up with very fast scattering and light bounces. And this is actually the splash screen for Octane 2, version 2. And that used to take 30 minutes to render, and here it's rendering in real time. We've also added things for real-time depth of field, real-time motion blur. These things used to resolve in tens of seconds or maybe minutes, not instantly, which is great. In Octane 2023, we've also increased the speed of motion blur for rendering by about 3.5 times, which is a pretty great speed up. And with the analytic lights, we call those spectron lights, we've added a number of new primitives, which include parallel lights, parametric lights, disk and tube lights, portal lights, dome lights, and we have a new mesh light that is much faster than the original version. We've also, along with all of the new post effects and other things that we've been showing, we've introduced a brand new post-processing stack, and that includes a GPU compositor node graph. There's been a little bit of that available in the current version of Octane since about a year and a half ago, but this one is much more sophisticated. You can do temporal compositing, you can write shaders, you can have textures that are embedded inside of the compositor, and you can then take multiple AOVs and you can blend those together with deep pixel, cryptomat, AI effects, video filters, and a lot more. This is a really cool example where we're actually taking a Hydra render delegate, which you can load in Octane 2023, it's the Storm renderer. You can blend that with the OctaneRender, and you can even write a shader at 60 frames a second that blends these two together in the viewport. So multi-render, being able to sort of take multiple renders at once and bring those together, even if they're not Octane, all doable in this new version. We've also added nodes for time transforms. Those are things that have been missing in the core of Octane for a while, but they're coming in Octane 2023. And we're working on light path expressions and something very similar to Arnold's output drivers for images for all the new AOV features that we're adding. I will say that there's also a lot more going into Octane 2023 than just the renderer. We've been bringing on a lot of partners, Moi 3D, which is a great modeler, Embergen, beautiful simulations and fire effects, Kitbash, Cascadeur for AI motion control, Architron for architectural sculpting and creation. And then we have our own data and art packs as well, including LightStage, which is our facial and body scanning solution. So this year we introduced human bodies and faces. There's about 100 scans a year that we've been doing, and they're really high quality. They can be blended and mixed together. And we're planning on introducing more and more tools that can leverage all these great assets. We've also added tools that leverage Vectron, which is our fractal OSL shading system. And you'll see some of these other modules as well that we're working on, including partnerships with World Creator and others. So in the core of Octane, we're working on adding multi-process failover so that if you have a crash on the GPU, it doesn't bring down the host application. And on the texture side, we're adding bitmaps, parallax occlusion maps. Those are things that are doable already in script nodes and OSL, but we want to make them core features. And we're also in the process of adding additive materials, volumetric user data, and rest position input, which is a long requested feature in Houdini. We're working on improvements to our fabric material, which will be in a new BRDF. And for motion blur and other improvements, we've got improvements coming for HDRI environments, volume instance motion blur, which is partially working in 2022 and will be finished in 23, and motion blur for texture displacement. We're also working on adaptive subdivision for vertex displacement and fully parametric spline and curve primitives, which will be, I guess, like native NURBS rendering. And those are using some of the new features on Ada and later GPUs. We're doing another set of features for Houdini, including UVW packing. This is something that a lot of Houdini users have requested. And we are also working on, I guess, what you'd call the equivalent of vertex shaders, real-time vertex shaders for geometry. And you're seeing that here. This is something that will work with ephemeral GPU instances, which is something that could be used for plants or trees that are effectively each have to have their own transform. There's probably a limit up to about 100,000 polygons, but you can have millions of individual meshes that can each be deformed this way. Similar to that effect, we are also doing geometric scattering across a mesh. So the GPU will be able to calculate scattering across surfaces. We've got a CPU version. Today, we're going to be moving that over to the GPU. And then we're adding support for OSL trace sets and more complex material layer operations, probably matching what's going to be put into the Academy for the Academy standard. Sorry. The other thing that we're adding in Octane is fluorescence and phosphorescence. This is in a build of Octane that we've had for about a couple of years. The reason why we haven't put out this along with polarized lighting is that it does have a speed slowdown, so we're working on resolving that. But if enough users request it, we might add it in. And of course, you now have GPUs that are so much faster that really it does make sense to probably consider integrating it towards the end of this year. On the third-party roadmap, we're adding support for Adobe Standard Surface, Material X, and also Hydra scene delegate support. So we'll be able to load, for example, Arnold's USD scenes directly through Arnold's node render delegate system, scene delegate system. Multistream is a brand new we're also introducing multistream. And multistream allows headless rendering, which means that if you're running, for example, Octane on an iPad or a Mac, you can effectively remote it to another machine. Here I'm showing Blender doing the same thing. You can do this over the internet. You can do it over Wi-Fi. It's pretty robust. And multi-render also allows you to do multiple rendering engines inside of Octane. Here we have our anime render that's running as a render delegate. You can load in any render delegate you want. You can load in, for example, cycles. And most recently, we've been showing tests with Autodesk Aurora, which is a real-time path tracer, runs on DirectX and Vulkan. And it's remarkable how far you can extend the rendering pipeline with third-party renderers that are built using Hydra's render delegate API. These all load into the core of Octane. And as we were demonstrating earlier, can be used with the compositor. Now, multi-engine is a different beast. It allows you to create, I guess, the equivalent of Hydra scene delegates as plugins and modules. For example, we have a sculpting system here, Sculptron, that's actually been released as its own app. But in this case, we can embed it as a node inside of the core of Octane, and it can drive deformations. This plugin system is really powerful. It can be applied even to an entire DCC like Cinema 4D, which is what we're showing here. We've licensed the entire Cinema 4D engine from Maxon, and we can integrate it inside of the core of Octane, even build our own node interface, which is similar to the Cinema 4D plugin interface. This will also be something that is loadable in other plugins like Houdini and Blender. And multi-engine is also really useful for Unreal, where you can have multiple nodes driven by Unreal that are also connected to Octane plugins and DCC tools. One of the more interesting integrations for multi-engine is World Creator. You can see here some of the beautiful work that's being done in World Creator and Octane for Cinema 4D by Aaron Rustwood. The idea is that World Creator has its own set of nodes and deformations, and there's no reason why those can't be expressible inside of the core node graph rather than having to go to a separate application. So this work that we're doing, I think, is designed towards creating a cohesive hub where you can leverage all of the different DCC applications that are out there that can be refactored into this form in this module system and have a really cohesive, integrated art pipeline. Another feature that we're working on for 2023 is photon tracing. It's similar to what we were showing for caustics, really fast caustics, except it's effectively caching all of the reflection and diffuse rays. And this is an example of that put into effect. You're seeing that also used on the iPad example before, but this shows that it's also something that can be leveraged right within the rendering itself. So you can cache while you're live rendering and then recast that for much faster live rendering. As we look towards future technology, meshlets are a really important framework that we're developing for later this year. Hopefully it'll ship by the end of this year. It's effectively Nanite for Octane. So Nanite is a system for Unreal Engine that allows you to load in almost infinite data from an SSD. In other words, it streams it into GPU memory. And that's what we built with meshlets. So here you're seeing about 36 gigabytes streaming in with a 300 megabyte buffer, and it's streaming in at, I guess here it's 400 frames a second. It's pretty fast. It's not leveraging the full shading stack, but it's showing how powerful the system is. And you basically don't have to worry about GPU memory or system memory. Everything streams from SSD. That includes geometry and textures. Here's another example with just a 50 megabyte buffer, and it's basically streaming a huge amount of data. And this is a 64 gig mesh that's streaming in a 1 gigabyte buffer. It's pretty remarkable, how this works. And the other thing that I think is super useful is that, of course, if you can express everything as a texture, for example, displacement, textures and displacement maps can be streamed in really quickly. This is showing a 128K by 120K texture that's effectively streaming in for about, 50 megabytes worth of texture memory. And it's incredibly fast. This is running at least 60 frames a second. So the system for procedural streaming, I think, is something that makes a lot of sense for production rendering, but also for real-time rendering as well. The next topic that I want to cover for our midterm roadmap is neural rendering. So neural rendering is something that we introduced last year at GTC 2022. And to recap, the way it works is that it takes geometry and it converts it into a perceptron. In other words, it uses a neural network to represent a 3D object in a volume, in a box. And we can render data into this neural network object. And similarly, you can also take data from external renderers or even images and turn that into a neural renderer as well. And the most common format for this type of object is a NeRF. But Octane itself has a system that can load a NeRF or can load an even more complex neural object, and it can do really interesting operations. The future of composition, I think, is going to be neural, not just triangles, not just ray tracing, but machine learning operations and generative art. I mean, I think that the stuff that we're seeing in the last 6 months proves how important that is to the pipelines of the future. And to that end, we're seeing Stable Diffusion. We're seeing Google, work towards video generation from text prompts. Runway AI is also doing great work in this respect. So really, there's no path where we're not going to be building these kinds of tools into Octane. And here's an example where we have neural nodes that effectively override everything from textures to displacement with textual prompts, right? So you can do 3D scenes this way. You can do, you can see here, I can just type in a piece of text into a texture, and I can do the same thing for a mesh. I can generate a 3D object. I can do scattering. There's many really complex operations that can be handled with neural rendering. This is a scattering system. I want to have shape of Mickey Mouse in a field of trees, and the scattering system is built from that. Obviously, infinite amount of substances, materials, patterns, textures can all be generated through AI, and this is all procedural, so it's incredibly powerful. And I think this makes artists have a lot more tools at their disposal. It certainly eliminates the need for a lot of external tools that previously were necessary. And I think the hardest part is probably geometry. You're still seeing generative 3D meshes that are kind of mushy, but I think when you're applying generative AI art to displacement maps, the results can be pretty cool. And I think when you're looking at a device like the iPad or the iPhone, having the ability to take voice input and control your scene is very powerful, really important. I think where I want to take the conversation next is to talk about what to do with rendering when you want to have provenance and you want to have unlimited compute. And these are things that the render network solves. Now, the render network is something that is apart and separate from our work on our core software renderer. The render network is a distributed GPU blockchain system. The concept is pretty simple. There's a ton of GPUs out there. There's hundreds of millions of GPUs. There's only about 50,000 or so high-end GPUs on the public cloud. And the demand for rendering and even AI jobs now is just enormous. So what we've done is we've taken the price of a GPU minute or hour on Amazon, Google, or Azure, and we've translated that to, I guess, what you would say used to be Ethereum miners. And the effect has been a huge amount of compute power that's being offered to artists. And we've also brought in our partners from the public cloud providers, including Google, Microsoft, Amazon, and others. There really is no limit to the amount of nodes we can connect on the system. And some of these nodes from Azure and GCP and AWS provide really high-end security. Now, as you saw with the Star Trek piece, not all studios need that, but if you do, we have nodes that are reserved for that purpose. But we do have end-to-end encryption, even on decentralized nodes that are running on end users' machines. We've also broadened the scope of render to include third-party renderers besides ours. So one of those is Redshift. We've done a long-term deal with Maxon to bring Maxon's C4D engine plus the Redshift GPU renderer, which is a great biased renderer. And we want to show an example of Cinema 4D and Redshift running on the render network. So this is a great example showing something that is not our code, not our rendering engine running on the render network. There you go, final render in Redshift. Pretty good. And we've added similar features for Autodesk Arnold. You see here using multi-render, you can actually switch between Octane and Arnold on the fly, which is pretty cool. And the render network will finalize that for you. And we expect to add pretty much anything that is a render delegate, hydro render delegate to the render network. But we're starting with these 3 renderers and going from there. The other types of jobs that we're adding to the render network are NeRF and light field renders. This is an example of how you'd set up a NeRF render or light field render in Octane. And this is the result. It effectively, on the render network, generates a NeRF and feeds that back into the rendering system. And you can still do ray tracing operations on there. NeRFs are pretty cool. As I was showing before, you can do light field renders. The NeRFs can also be used in AR, as you're seeing here on the left. It's a little bit splotchy, but it's pretty cool. And we have the capability to do really precise rendering with light fields. This is not a NeRF. This is an actual light field render running on an iPhone. And the light field is effectively providing all of the reflections and lighting information for at least 70% of the rendering. And that's why the phone is able to then render it at about 20 to 30 frames a second. And this is pretty great because it does allow you to do path tracing in near real time with an iPhone. Now, the other type of rendering job that, of course, we're adding is just straight up stable diffusion. You're seeing here on the left is the web interface for stable diffusion. And the ability for you to just type in prompts is pretty straightforward. But when you mix that with what you can do with rendering, there's some really interesting effects that you can accomplish. For example, you can mix Cryptomatte with the ability to do in-painting. And we also have an entire Photoshop application through Photopia on the web that allows you to edit your renders. You can take your Cryptomatte passes, you can blend these together, and you can run multiple generative AI jobs all on the render network from your render jobs. And I think the future likely pretends having the ability to mix and match these things all within a single rendering pass. Right now, this is sort of an offline process, but we can also bring all of this locally and mix and match that with your IPR and real-time viewport. Now, I think beyond this, of course, is large language models like ChatGPT. Really, about a week ago, Microsoft released ChatGPT 4, and you're seeing here Visual ChatGPT, which is on GitHub. It's Microsoft's framework for loading images into ChatGPT. And I think if you can imagine your renders or part of your render jobs, your render craft going into a large language model similar to ChatGPT and having your text drive and control that in ways that are very descriptive, it's, I think, even more powerful than what you're seeing today with Stable Diffusion and even ControlNet. So the future with AI, large language models mixed into the rendering process, I think, is absolutely crazy. And we're going to see a lot of that explode, I think, over the next 4 to 5 months. I want to talk a little bit about the Render SDK. It's our portable graphics API and compute framework. We use it to build everything. So it's our way of loading in modules that are both AI related, rendering related, compute related, and it's actually, you know, useful for building entirely new renders or additions to the rendering jobs that you've seen already. But we're opening that up to almost anybody, and we're also putting this in the hands of the Render Foundation. The Render Foundation is a totally independent establishment. There's a DAO. It was created at the end of last year, and it assumes governance over the render network. So it's no longer OTOY that's controlling the render network. It is this DAO. And we also have regular votes on codifying how the render network works. And most recently, we established a vote on the token model. So there's a new model that we're moving to, which is called Burnt Equilibrium. It's a BME model. It's similar to Helium, which is a token for Wi-Fi utility, and it'll be implemented later this year. Now, because Render itself is running on the blockchain, effectively everything that you're doing on it is already an NFT. You have a proof of render for everything. So even that one frame from that Star Trek movie is on chain. You have that receipt for it. Whether you choose to put it on OpenSea or sell it is up to you, but effectively all components of your render job are on chain, they have provenance, and we want to at least give people the ability to create totally new models around NFTs. And I think, to look at where this might go, you should look at artists like Pac and Beeple that are, some of the earliest adopters of both OctaneRender and NFTs. And the way that they're looking at things in the future is pretty interesting. So with Pac, for example, he does experiment a lot with generative NFTs. We have the ability to generate anything on render, and it's effectively already, encoded on chain. But what's more interesting is when you can take those experiences, you package them as a NERF or a streaming render job, which you can do on the system. And you can see here it's running back as a web page. This is the kind of thing that I think makes an NFT a lot more interesting, where you can take an experience, you can package that up, you can have others recompose it and add to it. And it can leverage everything from Unreal to Octane to Brigade to NERF to light fields. All of it is possible. You can even package an app. For example, we can have Octane encoded in an NFT, and you can sell access to it. So this is, of course, very metaverse-like. And I think the metaverse, in my mind, is spatial 3D on the web. You do need open standards, just like the web. And I think that's so fundamentally important. Without that, I don't think you're going to end up with a metaverse that any of us really want. And to that end, we've joined the Metaverse Standards Forum. We're also part of IDEA, which is the open source group that's taking our Orbex data format that's coming out of Octane and Render and turning that into an open spec. And the Metaverse Standards Forum, I think, is a really promising endeavor towards that goal. It complements all the work we're doing in IDEA. And we want to put these open standards to practice with projects like what we're doing with Alex Ross, who's a good friend and an amazing comic book artist whose great work you're seeing here. Alex and I have been thinking about the metaverse for, my goodness, about 10 years. We collectively with John Carmack did Render the Metaverse with Oculus. And we're taking all of his work, his life's his life's work of art, I guess, over the last 30 years, and effectively building 3D models, encoding that on the chain, on Render, and having that at least there for posterity. And the work that we're doing, of course, from Alex's corpus of art is enormous. It covers everything from Marvel, DC, sci-fi, most of pop culture in the last century. And as we're looking at the ontology for how to categorize all of this amazing work and many other artists that can link to it, we decided we needed an index. And that's where the M token was created. It's effectively an abstract concept token. And it allows you to link data through concepts that are defined on Wikidata. And with this, you can actually have some sort of concept primitive that allows you to define how stories are interconnected, characters are interconnected. You can link everything from fandom.com to wiki pages to Notion documents. And these are things that are effectively really important for having ground truth for content and IP. And we're going to put this to use for the Alex Ross archive and also for other archives as well. And that includes Beeple's archive. So I'd mentioned this project going back to 2021, and I also brought up Beeple's interest in going beyond NFTs. And I think that he's done some remarkable work exploring conceptually how digital art can be represented in a form that is respectful of the artist, that is deep, that is profound, and that still has a lot of value when you're buying effectively a unit of it on chain. And a lot of what he's been exploring have been concepts related to generative art, time-based art, physical art. This is an example. It's one of my favorite Beeple pieces of art. It's from 2018. It's one of his everydays, and he let us borrow it to show how we could use it in all these different forms. You can load up the piece of art as an Orbex file in the iPad app. You can load it in a browser stream, which we're doing through XIO here. And more interestingly, we can package it up in a configurator. So this is where some of the concepts that people has had around being able to create art in a time-based fashion by remixing his own work or his own concepts has come into play. These are screenshots from a test that we did last year with Mike. And the way that it works is that you have a certain amount of time. See here, you have a stock scene from one of his everydays. You can then bring in objects from his other artwork and other pieces of content. And within a certain amount of time, you get to make your own everyday as well. And it's a lot of fun, and it's beautiful. It's easy. You effectively get really beautiful renders out of it. They get rendered on the render network. And it's just an early experiment, but it is something that we want to work with people on integrating in the coming months. And here it is running in real time, which is pretty cool. So one of the things that probably connects what you just saw to Mike's future work is his own experiments with time-based art. So I was actually just at the opening of People Studios not too long ago. See here, it was an amazing event. He's got a lot of physical art on display. And one of the things that he did at the opening was he made about, you can see here, about 20 or so pieces in a couple of hours. And the idea was that he was showing that the way he sees art, it can be created in a time-compressed fashion, and the tools that are evolving allow us to do that. As you saw in the earlier example, those tools are now available on the web, and we can hook up Octane to that and really make it even simpler than any DCC. So there is a lot of merit to this kind of thinking, and it's something that we think is a huge part of where NFTs and digital art and even consumers' intersection with that might be heading. And the other thing that's a big part of people's focus is connecting his digital work to the physical world. You see here, I'm at the at a studio with this mountain of everydays. There's about, I think, 8,000 on that wall. It's an enormous amount. There's also a lot of physical art that's there. And one of the really interesting pieces is this one, which is it's basically 4 LED panels that's meant to simulate a holographic box. But we are bringing the Light-Field Lab display panels to fruition here, and we want to develop this very same workflow that people's been developing on just normal LED panels with holographic display panels. So those things have about a gigapixel of rays to shoot out. So it requires a huge amount of GPU power, but over the next few years, we think it'll become tractable, and it'll be physical art like this that can push the envelope and make something like that really beautiful. The last render archive that I want to cover is one that is near and dear to my heart. It is the Gene Roddenberry Render Archive. We announced this on Gene's 100th birthday, his centennial, a couple of years ago. And like the other render archives, it's meant to cover his entire corpus of work. In the case of Star Trek, though, you're dealing with 60 years worth of stories and history, and I mean, it's 800 hours of television, 13 movies, just an enormous amount of work. And so we started modestly enough, just scanning in documents going back 15, 20 years. This has been a project that's been in development for multiple decades. But a few years ago, Rod Roddenberry, Gene Roddenberry's son and my partner and a very close friend, decided to take things a step further and start to build the things that are in Gene Roddenberry's lifetime of work as visual artifacts, including the USS Enterprise, a life-size version and a production version that would represent what was filmed. And so this sort of modality has really been promising. It got a lot of attention, and the goal of this project is to effectively build a life-size digital twin of the USS Enterprise, as you'd seen it in the motion picture and the TV shows. And we've actually gone about 30% of the way there. We're about a year and a half into it. We probably have another few years to go before it's completely done. But the work already is just breathtaking. It's beautiful. And it's not just the Enterprise. We're actually building the environment around it. So we have a one-to-one life-size Earth. You have a one-to-one life-size universe, solar system. At least within everything that's documented in Star Trek, it's there. If it shows up or it's mentioned in a Star Trek episode, we build an equivalent of it, and we try to make it as real as we can. And within that context, the micro and the macro are both represented at this incredible fidelity. You can see here we're also carefully matching the things that were in the movies and the TV shows and making sure that they are visually identical. They're also explorable and interactive. So you can go through the engineering section and push the buttons, explore the bridge. It's all meant to be like a museum, a living museum that you can walk through and explore. And this is the bridge from the motion picture, Star Trek motion picture from 1979. Gorgeous piece. Going forward chronologically, here's Star Trek II. You can see here the first couple of movies almost nearly perfectly matched. And of course, we have to go further than just the sets and think about characters, and I'll discuss that in a little bit. But we have 30 years of engineers and designers and artists that have been working on Star Trek that are giving us all these blueprints, all these plans to figure out how this all goes together and how this fits in within the timeline of Star Trek. So it's not just one enterprise that we're working on. We have to think about the fact that the ship itself changed over the decades and the years as the show went on, and the movies followed that. And even after the Enterprise was retired, there was future Enterprises. There's actually 14 in total and counting from the different eras. And one of those future Enterprises is the very popular one from the 90s, Captain Picard's USS Enterprise, which you can see here. He ended up having, in fact, 2. This is from the Star Trek The Next Generation movies. And we build these things in a combination of Blender, Unreal, Cinema 4D, all of which connect to Octane. And the attention to detail, again, this is one of the more recent examples. You go to Picard's ready room, you'll see that there's sculptures of his ships. His fish from the from the 90s episode is perfectly well represented. It really is a world that's brought to life in exquisite detail, and I think that's truly where the metaverse, is heading. Something that is beautiful like that, I think, is meritorious of the moniker of what we want to see in the metaverse. This is some of the work that is coming ahead for the Roddenberry Archive in the year ahead, and we've got everything from other shows like Deep Space Nine and Voyager to the J.J. Abrams movies to the more recent Strange New Worlds, or Star Trek 3 and 4, which complement the other movies, bridges that you'd seen, and Star Trek Enterprise, a show from 2005 that I mentioned earlier, and even some of the work on the early sketches for unproduced Star Trek movies is something that we're taking a very close look at. There's a big part of this project that involves taking things from the real world, and photogrammetry, of course, is something that's well known to a lot of artists. We've got Lightstage, which does this absolutely breathtaking scan of digital objects and assets. You see here, this is the phase 2 physical model, the blueprints above, and the renders on the bottom right. And thanks to collections from the Paul Allen Estate and others, there's just this incredible wealth of physical artifacts from Star Trek that we can scan in and create digital doubles of. But we don't need to do that. We actually have such incredible artists on staff that they can pretty much create these assets from whole cloth, like you're seeing here. But we do, when we can, have both the scans and the physical assets and the digital versions replicated where we can. And in cases where they overlap, well, then we have both. And you can see what the physical asset is and the digital recreation is. And there's a need for both of these. One of them is something that's meant for posterity. The other is meant to be used in a in-universe interactive experience or even virtual production. And in those cases, a scan is not necessarily going to be the best version of what you want to have. You want to build it from scratch or have the scan inform the digital version. You see here some of the interactive pieces that are enabled in the digital one-to-one USS Enterprise. Bathrooms work, toilets flush. It's pretty crazy. I do want to mention that we've been working with NVIDIA on this project as well. We showed some of this work last year. We've been making sure that what we're doing on the Roddenberry Archive also connects to NVIDIA Omniverse. And yes, we have connections to Unreal, but with Omniverse, there's also a wealth of DCC tools and workflows that are really valuable. And so being able to take everything that's in the Roddenberry Archive and have an Omniverse connector through Octane that can bridge these things is critically important. And I think that also leverages a ton of amazing work done by the NVIDIA Omniverse team going forward. And we're excited to take that further in 2023 and 2024. We've been working with Roddenberry, CBS, and others also to create industry standards around USD. Of course, Omniverse leverages USD, and I think that's one of the fundamental pieces to all future metaverse standards. USD is a pretty great piece of that system. And with Material X and OSL shaders and other things attached to it, I think there's a lot of momentum behind that as an open standard for the metaverse and possibly for digital art and collectibles going forward. So the story of Star Trek is something that is just as important as the assets and the renders and the images. And so as we were looking at archiving that, we started at the very beginning last year with The Cage, which is the pilot episode of Star Trek that was filmed in, you see here, November 30th, 1964. And when we put out the first bit of the Roddenberry archive that was related to The Cage, it got a lot of great attention. As you can see here, we brought in performers, actors, and we even brought in the director, Robert Butler, who directed that pilot episode 57 years earlier. It was an incredible experience. I want to play a video showing the interview we did with him. I was very nervous bringing Bob Butler in, showing him what we've been doing. Having his thumbs up, it gave me goosebumps.
I was aware of the size that this show has become. I saw the size there. I saw the size here. Testimony to the quality.
It's been really rewarding to see the feedback from those that actually worked on the show coming in and seeing the world of Star Trek as they remember it brought back to life. That's where the magic of the work that we've done really kicks in. We're at the point where we're looking to rebuild and reconstitute these uniforms digitally, physically, scanning them, putting a performer. There you go. That's a remarkable testament to get from the director of that pilot episode. And you can see here, we have a digital pipeline, physical pipeline, a scanning pipeline, but it all sort of comes together and the results are just beautiful. You're seeing here 1964, 2022, it's almost indistinguishable from the original. And the results just look beautiful. I mean, in fact, as we're taking things from the 60s, we want to render them as they were in the 60s. And as we go into the 70s, same thing, right? So there's a lot of work that goes into just figuring out how the cameras and the lighting and the films and the emulsion of plates work to get everything to look just right as it did back in the back when the shows or the movies were filmed. And going back to the virtual production side of things, the piece that I showed earlier had a predecessor. Let me play it for you. So that was the very first test that we did before we put out the longer 1 minute piece that I showed earlier, and that actually had 1.5 million views on YouTube. It was something that organically got a lot of attention. A lot of the pieces that you're seeing come from Star Trek literature, not necessarily the movies or the TV show. About 40% of the story of Star Trek, believe it or not, comes from the novels, the comic books. You can see here we're matching those pretty closely. And a lot of the stories that are in those books inform and create the things that end up being filmed later on. So they are really important. And some of those important stories are actually written by Gene Roddenberry, and they were unproduced or extra drafts of things that really show a lot of the intent of the creator. And that's something that is more important to us in some respects than some of the minutiae of the episodes. So for us, capturing the things from the novels, the books, the unproduced drafts of Mr. Roddenberry, these are all things that are driving, I guess, the five-dimensional world line of the Starship Enterprise and the story of Star Trek. I want to focus on the characters. Now, in the case of Yeoman Colt, before we had a performer that looked just like Laura Goodwin, the original actress. In the case of Spock, we started with the CG Spock. I showed this 3 years ago, and you can see here the CG Spock was being used for a shot with him in a helmet. But when it came time to having that performance be brought into motion, it just didn't make sense to have it being done any other way than with an actor and a performer. So I had mentioned before we'd had a performer, Lawrence Selleck, using a combination of heavy prosthetics and a digital makeup, which you can see here. Those were added for the eyes. the combination is pretty great, but it's still a lot of work between the physical and the digital. You can see here, poor gentleman was ensconced with a lot of prosthetic makeup. We have our digital Spock model here on the right, and the combination is pretty great. We basically 3D printed all of the digital pieces, put them on his head, and it looked great. The problem is it was difficult for him to move and do a performance with the prosthetics on. So the digital pipeline that we came up with, which works, by the way, completely in real time, as you're seeing here, allows us to mix and match the digital and physical prosthetics as needed, and the performer can do their job really without any markers. And this is all being rendered and lit live on a 3090, actually. We have another tool in our arsenal here, which is we can scan in the actors with super high fidelity, as you're seeing here. And then we can do effectively camera motion after the fact. This is incredibly useful for relighting. This also means that we are able to effectively direct the shots after the performers have done their piece. And it's not usable in every single instance, but it is something that when you can put two performers in the middle of this capture volume, the results are pretty spectacular. And we did A/B testing, in fact, ABC testing, where we effectively tried this method with more traditional alternatives, where, for example, in this case, we had green screen or NURFs, in fact, which we tested alongside the digital scan. But the digital scan version of the performance actually ended up being the one that was used in our final render. The quality was phenomenal, and we did an A-pose of the performer and then had a machine learning algorithm track their movements and then move their body in motion. And that's what you end up seeing for about 3 or 4 of those shots in that piece. And we put that to work as well for Lawrence's performance of Spock. As we move forward in the virtual production pipeline into this year for the Roddenberry Archive, we're actually doubling down on creating a lot of physical assets and props. Our virtual set before was purely digital, including the chair. Now we're building these physical chairs. We've also acquired a lot more assets to scan in. Even digital characters that we had created for a previous short. This is Arex, who was from the animated series, all digital. Incredibly popular. People loved that we created that digitally. So we went ahead and we built this physical 3D printed model, which we've scanned in and can mix and match that with physical performances, which is pretty exciting. We've also started to figure out how to capture large environments. This is done with Luma Labs and a drone. Luma Labs makes great software for NURFs, and those NURFs are available effectively through an API to be brought right into Octane's neural rendering system. And you can see here the NURFs are awesome. I mean, they do capture everything from clouds to far field objects. I mean, they're spectacular for doing really complex captures. And in the next slide, I'll show how it looks inside of Octane. Effectively, a NURF render can be treated like an SDF with various reflections properties, but the quality is pretty good. And we've also mixed and matched various different things. We don't just use NURFs. We also have laser scanners, and there is some work that's done by the digital artists as well to provide a final render. So it's a mix of many different systems and tools, but NURFs are relatively new. They weren't really a usable asset framework a year ago, but they are today. And that's pretty great. For the character performances, what we did last year with Spock was really focusing on a single version of Spock. There was one age that we focused on, which was one here in the middle, which was the motion picture. But Leonard Nimoy played Spock over 50 years, and we've similarly had to have Lawrence figure out how to portray Spock over those same 50 years, and it's been challenging. We've been able to build a full 3D version of each of the heads that he is driving through his performances, so we can age them, relight them, and even bring them, as you can see here, into the iPad app. So you can see here on stage while we're filming, we have effectively the ability, we play that again, we have the ability to relight and move the camera around as we're doing the shoot, and it's pretty powerful. So you can see here's the set, here's Lawrence. We're doing a real-time live performance of his face, and it's connected to the Octane asset that's being shown here on the iPad. We can change the lighting, and it can adjust the lighting in the virtual production stage as well. And this can happen while the actors are doing their performance, while we have people on set. It's very early part of the pipeline, but we're putting it to good use for the current project that we're doing. And we're also going insanely detailed on geometry. This is for the this is all rendered in Octane, and this is for the new piece that we're working on. It's by Aaron Westwood and JJ from BLR VFX. It's gorgeous, and can't wait for people to see this piece. It's going to be amazing. We also have many other artists that are working on building beautiful, crazy worlds that are pushing the envelope for meshlets and other things that we want to leverage going forward in the future. And the future of rendering is very much in the hands of creators, and the tools for rendering are becoming easier and more powerful and better. And I think that virtual production and virtual worlds go hand in hand, and you're going to see a lot of beautiful work being done by everyone that's in the digital art space, and possibly a whole new swath of consumers that get exposed to these tools with utility through AI and other systems that make this much easier than it's ever been before, and hopefully democratizes the content creation pipeline for artists. And we have to remember that at the end of the day, really, artists are humans. And I think that as great as AI and all the tools around them can be, it really is important that humans are at the center of content creation and the experience between all of us as we appreciate and love the art that gets created. Thank you, everyone. This is GTC 2023, and I'm Jules Urbach signing off. Take care, everyone. See you next year for GTC 2024.